everyone, my name is Arsalan Farrukh and I teach math and physics. In this video, I will give you a brief introduction of complex numbers. So basically, when you solve a quadratic equation and apply a quadratic formula, sometimes you could be in a situation where you have a negative sign inside the radical sign. And many a times what you do is that you stop at this point and you say that this is a complex root. This is an imaginary or unreal solution of the equation. But in complex numbers, we actually move on from that step and we start dealing with these numbers as imaginary or complex numbers. So if you ever have an under root of -1, then you can suppose that under root of -1 as small I. It is read as iota. So when you replace this under root -1 with an I or iota, you will get yourself the imaginary form of a number. So like in this case, you're getting x equals 1 plus minus 2 iota. So basically you're getting two complex roots. One is 1 plus 2 iota and the other one is 1 minus 2 iota. Since you've identified that under root of -1 is equal to iota, you should also be able to identify that if ever you have iota square, that would simplify as -1, or you can simplify any higher power of iota as well. For instance, if you have to simplify iota cube, you can split it up into iota square into iota. And iota square will become -1. Or if you have iota to the power 4, that becomes iota square whole square, that is -1 whole square, and that simplifies to 1. So likewise, you can split any higher power of iota into iota squares and get the value of iota square as -1, and you can simplify them. So once you have a complex number being written down in the form a plus iota b, then this part of the complex number is called the real part. So A is the real part of the complex number and B is called the imaginary part of the complex number. So we have certain notation to represent that as well. The real part of a complex number is REZ, and that is A in this case. And imaginary part of the complex number is written down as IMZ, and in this case that is equal to B. Please remember that whenever you're picking an imaginary part, you don't pick iota with that. So it is just the multiple of iota that you're going to pick here. Another thing that would be useful for you to identify is the conjugate pair of a complex number. So whenever you're solving a polynomial equation, you will always get yourself complex numbers as conjugate pairs, which is the imaginary part would come as both plus and a minus sign. So there will be a +1 and there will be a -1. So the conjugate pair is the same complex number with the imaginary part having its sign being reversed. So 1 plus 2 iota will have a complex conjugate as 1 minus 2 iota. So every time you're solving any quadratic or cubic equation and you solve your equation and you get yourself a under root of -1, you can always replace that under root of -1 as iota. And whenever you replace under root -1 with iota, you will get the imaginary solution of the equation. Now, sometimes you might get a situation where you have to write down the conjugate pairs of the given complex number. So if you have a 3 plus 5 iota, its conjugate pair is going to be 3 minus 5 iota. Or if it's 4 minus 7 iota, its conjugate pair is going to be 4 plus 7 iota. If you are simplifying two complex numbers in terms of adding or subtracting these complex numbers, then you can add the real parts together and you can add the imaginary parts together. So you will get an overall simplified result of the addition or subtraction of two complex numbers. Similarly, you can also multiply two complex numbers, and whenever you're trying to multiply two complex numbers, you can just simply multiply. Like if I have a product of two complex numbers, I'm going to multiply all the terms together. 3 times 2, 3 times 3 iota, 2 times iota, and iota times 3 iota. That becomes 3 iota square. And then you would realize that iota square is -1, and you can also write it down as -3, and hence you will get your simplified result of this. So likewise, you can solve even product of two complex numbers, or you can also find out the higher powers of these complex numbers by expanding them. Now similarly guys, if you have to divide two complex numbers, there is one thing that you have to do as a standard, and that is that you will identify the conjugate pair of the denominator and multiply and divide by the conjugate of the denominator. So if I have to divide 3 plus 4 iota by 1 minus 2 iota, I'm going to multiply and divide with the conjugate of 1 minus 2 iota, which will be 1 plus 2 iota. So the numerator will simplify together. 3 times 1 will become 3. 3 times 2 iota will become 6 iota. 4 iota times 1 becomes 4 iota. And 4 iota times 2 iota becomes 8 iota square. In the denominator, you would always be able to simplify easily by applying the formula of a plus b into a minus b. That would be equal to a square minus b square. And that would be the advantage of it, that you would have a square over iota, and that will simplify as a real thing. So if you have a real denominator, you can split it up and you can get yourself a simplified result. This is how you would always divide two complex numbers. Now let's have a look at another example. Let's say I have to simplify this thing. I can either do it by first taking an LCM and then simplifying it and then rationalizing it, or what I could also do is that I can just rationalize both the functions together. So to simplify 1 over 2 plus 3 iota, I'm going to multiply and divide it by 2 minus 3 iota. And to simplify 1 over 2 minus 3 iota, I'm going to multiply and divide it by 2 plus 3 iota. Simplify these two separately and then add them up together, and I will get myself the overall simplified result. And this is another example that has also been done in a similar way. 1 over 3 plus iota is being multiplied and divided by 3 minus iota, the conjugate of the denominator. And 1 over 1 plus 7 iota is multiplied and divided by 1 minus 7 iota, the conjugate of its denominator. You simplify both the terms separately and then add them up together, and once you will add them up together, you will get an overall simplified result. So whether you have to add fractions or you have to divide two complex numbers, you will use the rationalization process where you multiply and divide by the conjugate pair of the denominator. Also, you can keep that in mind that if two complex numbers are equal, then their real parts and their imaginary parts would be equal separately. So if I have an equation like this, I will simplify the left hand side and then I will equate the real parts together to form one equation, and I will equate the imaginary parts together to form another equation. And after making two equations, I can solve these two equations simultaneously and get myself the values of a and b. So the point is that if two complex numbers are equal, then their real parts should be equal together and their imaginary parts would also be equal together. Guys, I hope you liked the video. I hope it clarified some understanding about the introduction of complex numbers. I'll post more videos to make you understand more concepts related to complex numbers later on. And I would really appreciate if you would like, subscribe, and share with your friends.